negatives and the positives were the areas that you guys struggled in. So be careful with those. All right, heading into example 1. When you're told to multiply stuff, a positive times a positive, positive times positive stays positive, right? So you end up with a positive 40. I can say the same thing about a negative times a negative. It becomes a positive. So negative 5, negative times negative, a negative number, I'm sorry, becomes a positive 40. So same sign, positive result. When there's two factors, same sign, positive result. And that's the rules for multiplication there a little bit lower on. It's actually after example 1. Negative 5, positive 8. So that is opposite signs is going to be a negative. All right, and the same would apply if this was a positive. That's a negative. Positive, negative, negative. Okay? Those rules are easy to trick up if you don't commit them to memory, so please make a point of knowing those things. Regarding the factors, so I have two factors here. This is your standard multiplication factors, right? You learn those in 3rd grade, but sometimes you receive a list of factors. So here's a little tip. If you have multiple factors, here's how you know which sign the end result is. An even number of negative factors will equal a positive result. So let's just say even number. 6 times negative 2 times negative 5 times negative 1 times negative 2 again. Okay? There are 4 negative factors. Therefore, I know whatever the result is going to be a positive number. Okay, I stopped thinking about it as soon as I counted the factors. Okay, as soon as I counted that I had 4 negative factors, which satisfies this, therefore my product is positive. In contrast, I'm sure you can handle an odd number of negative factors. The result will be a negative. Your result is going to be a negative. So, negative 6, negative 2, well, they're all negative, but I'll do it anyway. Negative 5, I'm using the same numbers. Negative 1, negative 2. Before I figure it out, 1, 2, 3, 4, 5 negative factors, negative 120. Okay? So it's all about even numbers or odd numbers. Evens create positive results. Odd creates a negative result. Which holds true when you think about it. Here there's 1 negative result. Here there's 1 negative result. And that continues on and on and on. Here's the last thing I want to share with you. So if you want to get your calculator started, you can, because I want somebody to check this. If you want to check that for me, Philip, that would be great.
Zero.
So anyways, it doesn't matter I threw you under the bus there a little bit. I could put 6,700 numbers here, and then that 0 means forget about it. It's a 0. Philip's like, seriously? He's going to throat punch me in a second. All right. So, regardless of the number of factors, any times 0, end result 0. Don't even bother. So that's another thing you can search for. Okay? By the way, all of this is kind of a conglomeration of example 2. There's example 2 for you. With variables, all of these truths hold because the variables have a coefficient. Even if it's a 1, variables will have a coefficient. So I'm going to go ahead and flip here in just a second and work with you on the variables that you're going to see in examples 3 and 4. So example 3, if I say 6x multiplied by negative 3y, the result is going to be the product of the numeric numbers and their corresponding variables. Negative 18xy sound about right? Negative 18xy is going to be your answer there for my first sample that I have for you. And addition rules, not really sure why they're introducing this except for the property of opposites, but that was in addition. But anyway, I'm going to remind you of that because they threw it in here as well. Negative 3x plus 4x. Okay, negative 3x plus 4x. The result is going to be the combination of the coefficients times x, right? 1x. Sound like your result there? So in essence, I distributed the x out from this sum. We're almost done, folks, I promise. Here is the last sample for you. Multiplying when you're distributing, a tremendous opportunity for failure. Trust me, I know. Here we go. I can't tell you how many times I've worked one of these and just flipped something and then said, what am I doing wrong? I'm a teacher. I should be able to figure this out. But it's just something stupid that happens. Negative 6 times a positive 1a, it stays negative. Negative 6 times a negative 5b, so the negative negative becomes a positive. Okay? Watch out for those negatives. That, if it doesn't have a positive in front of it, it's understood, as long as there's no negative there. Negative times a negative, due to the rules, is a positive. Go away. Go away. All right. Here we go. Next one. Last one, as a matter of fact. Actually, no, I have 2 more to do. So here we go. 5r minus 3 times 2r minus 9. Okay, right now the 5r is just going to get ignored for a little bit because we need to deal with the negative 3 multiplied by the 2 pieces within the parentheses, right? You end up with a product here of negative 6r plus 27. And again, we can undistribute the 5 and the 6 from the r, which I know you're not going to do that. Negative 1r plus 27 would be the result after you found the 5 and the negative 6. Really last one. Last one. Okay. Notice there's no coefficient preceding this, or there's no number preceding this parentheses. But that negative, as if there was a 1 there, needs to be distributed into the parentheses, because what is being subtracted is all of this, minus this mess here. So the 3x continues to linger, and you end up with something like this as your end, x minus 1 as your end result. Very good, Ethan. Be very careful with this. This is the most common mistake I still see in Algebra 2. The forgetting of the negative that preceded any stuff in parentheses.